Yes, I'm going to present. So please confirm I'm audible and OneNote is visible.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, fine. Okay, all someone joining. Just going to start the class. Okay, unit number two. So in unit number two, there is the syllabus like that: function of two variables, limit, continuity, and partial derivatives. Okay, and then we start the derivatives of higher order and their commutativity properties. One there, Euler's theorems on homogeneous functions. Okay, so first we start today the limit and continuity. Unit two. So first, function of two variables. Function of two variables. Okay, a function of two variables we can define like that. This is the function of two variables, like x square plus y square. Okay, it is can be also be denoted by something like that: 2x plus 3y. Okay, it's not only xy. We can also define like u of uh, some places some x z. Okay, so 2x plus z square something. This is the so what we are getting. So in this case, domain. So domain is what is which is defined like this manner, which is there are the 2 points such that where x is maybe plus 2 minus infinity and y may be minus infinity like that. Okay, So here the function such that s to r real number. Okay, and what is s is the r square. R square means Cartesian coordinates. So s means the value of function is just belongs to the real numbers. Okay, and s is what? S is subset of r square. Okay, these things you know already. This so function of two variables. Now we know about the neighborhood. Just like neighborhood, that means neighborhood of a point. Okay, so except the point, all the surrounding points very near to that, that is what the neighborhoods, and that we define under the some limit, just like in the limit and continuity, something already in the function of one variables. Okay, see the neighborhood. So neighborhood there are two types: N E I G H O, neighborhood of a point A comma B. So there is the square neighborhood. First is what? Square. BOUR neighborhood. So what is that? This is the point. Definitely it is represented by this is A and B. Okay. That is the okay, it is a straight line. So write and one more. Okay, I'm drawing approximately. This is the points here only. This or simply better to this. I should write this one. And this is the line means parallel to the x-axis. Another one is the perpendicular to the axis, that is parallel to the y-axis. Okay, so we can write such manners. So here is what is the point represented. It just like middle, and the middle is there, and this is the point is a comma b. So these point here. So this you can see. This is y is equal to b minus delta, and this is y is equal to हाँ ये सेल क्या बजे तक है 4 बजे तक फिर तुरंत फिर हमको भागना हॉस्पिटल में क्या हो कुछ पता चला पापा को अभी नहीं वही डॉक्टर बुलाए अभी क्लास के बाद वो एमआरआई में क्या हुआ वही शायद रिपोर्ट कुछ आया होगा तो इसीलिए बुलाए तो बुलाए वही 5 बजे तक तो क्लास ज्यादा नहीं है ना अभी कुछ बात नहीं हुआ अभी जाएंगे तब सुबह में तो गए थे लेकिन बोले रिपोर्ट अभी आया नहीं है तो 1-2 चल ठीक है तू पढ़ा ले मैं चल ये इसी को ले जा रहा हूँ हाँ नहीं ठीक हो गया आज तो अपना काम देखो हम तो ऐसे ही मॉर्निंग मेरे को अब लगातार कितने देर काम कर यस ठीक है तो अपना काम ओके okay, come to this point. So x, this is x is equal to a minus delta, and this is x is equal to a plus and delta. So it's represent. This is the part of that equation of lines. Okay, so this making the this is the square neighborhoods. Okay, square neighborhood, just like we have in the for the single variables that are occurring on the either in x-axis or y-axis, something like that. Okay, but in the function of two variables is occurring in the, but not only this, the neighborhood, there is other one also, that is the square. Yes.
सर नोटिस के लिए वो स्टूडेंट सेक्शन बोल रहे हैं कि आप साइन करा के लाइए ऑनलाइन।
और सर तो लंच के लिए चले गए हैं, अब मुझे अभी, मैं, मेरे हाथ में कुछ नहीं है सर जी। ठीक है, आप ऊपर जाइए, ऑफिस से कॉल करवाइए, ये नहीं पता सर कब आएंगे, बट आएंगे जरूर। ओके, हाँ आएंगे, लेकिन एक डेढ़ घंटे के बाद। ओके, square neighborhood, and second one is the circle circular neighborhood. Circular VOUR. So in this same things, we write, we can draw like in circle manner. Okay, I'm writing same place. It's not. This is the circular neighborhood. So neighborhood point. Okay, in the square neighborhood, what we write, x is mode of, sorry, x minus a less than delta, and y minus is b is there less than delta. Okay, delta is means very small but not zero, where delta greater than zero is very small but not zero. Okay, these things we writing for the square neighborhood. In the circle case, we writing circle. We know that the equation of the circles means what we write, x minus a whole square and y minus b whole square. These things is equal to delta square. Delta is the means radius, so that's very small. So or you can say like this way. Okay, that is not the defining the neighborhood. When it is defined, when we write this term, defining the neighborhood, or we not writing like a square means this form, but we writing x minus a whole square plus y minus b whole square less than delta, this one. So this representing all these things, we can also write x comma y minus a comma b modulus less than delta. So this representing the circular neighborhood, another one representing the square neighborhood. Okay, I'm just representing in the same graph. So this neighborhood, and this is the um, circular. Okay, so I think you understand the neighborhood now. So all the points near to this one and representing the neighborhood. This one means delta defining the range that's coming inside this circle. That's are called the circular neighborhoods and the square neighborhoods in similar manner. Okay, now we're going to define the limit of a function in the two variables. Okay, limit of function two variables. Ah, yes, you need a sign.
यस कन्वर्जन के लिए
सारे पे कर दिया, डेट लिखना है क्या?
सभी
हम्म,
वीडियो
24 और कोई हो गया?
यस
ठीक है,
थैंक यू
ओके। Limit of function of two variables. Okay, the definition is like same way epsilon and delta form we can define. Okay, and other things is same manner like function of one variable so two variables the manner is same. Okay, we writing all the things. Um, Function f of x y is set to tend to a limit L. L is limit same we are assuming as the point xy tends to point AB, not xy. This is AB. If corresponding, okay, if for given epsilon, if for given epsilon greater than zero, okay, that is small but not zero. We should write very small, not zero. So then there exists what delta greater than zero, such that modulus of function of xy minus L, which is less than epsilon, for modulus of x minus a less than delta, and modulus of y minus b less than delta. Okay, we are not right supposing like delta 1 and delta 2. Okay, the square and the circle in that case means delta should be only 1. Y minus b is the modulus. This is the epsilon delta definition of the function of two variables. Okay, now you know the things. Now we come to the problems. How we calculate the means solve the problems in epsilon delta. Question one. Let A is one set is there x comma y such that x is less than 1 and greater than 0 and y less than 1 and greater than 0. So these are the ranges of x and y. Okay, and we will is the set subset of the real numbers. No, sorry, this is the domain. Domain is subset of the R square. Let f function such that R defined by function of xy is equal to x plus y, so that a limit of function of xy x comma y is equal to half. Okay, as this one tends to 0 and half. Okay, same we are writing. So limit of function of x y is equal to as this one. Or we can directly write simply you show that and the rings are given. Means domains are given. So when we take x is equal, we take so we will get the half simply. We know this one, but we are going to solve that by the epsilon delta form. So by the epsilon delta forms, what we do from where we start from the this modulus value. We assume that let be given. Okay, so then modulus of function of xy minus L less than epsilon. Function of xy what? X plus y minus is half less than epsilon. Now what we do? Now we can write x plus and y minus half in this manners. We can write less than epsilon. And by the properties of the modulus, we can write mod of x plus mod of y minus half less than epsilon. Okay, or we can write x minus 0 plus y minus half less than epsilon. So in this case, we have to separate out. Okay, so what we equally distribute this one, x minus 0 less than epsilon by 2 and y minus half epsilon by 2. Okay, so when we add this one, we will have what? Epsilon by epsilon. Okay, so therefore, what is here? Epsilon by 2 is equal to delta. So which is our required relationship, epsilon and delta. Okay, so when we assume here epsilon is 0.05, so delta is divided by 2 is there. Okay, so like application part is same just like in the single variables. Similarly, we can do the double variables or more than the one variables. Okay, in the high dimension. So when we get such type of things, okay, hence if function is x plus y minus half less than epsilon, then mod of x minus 0 less than delta, which is epsilon by 2, and y minus half is less than delta, which is equal to epsilon by 2. Thus, hence, hence, limit of function of xy is equal to half as xy it tends to 0 comma. Okay, this is proved. Okay, similarly you can do the other problems. Okay, we can do also using like here we form here the neighborhoods. This neighborhoods is what? Square neighborhood. Square neighborhood we have formed. When we consider in terms of the rectangular, rectangular square neighborhood, we come to the what circular neighborhood. So what we do, you know that the things here circular neighborhood. The circular neighborhood function of xy minus 0 half. This is next what we write. So x minus 0 whole square plus y minus half. So these terms we are not getting from the epsilon. Here the things need to change some other way. Hmm. So we can write. x minus 0 plus y minus half. And this is the property a square plus b square, which is less than modulus of a plus modulus of b. This is the properties, we know that. So by these properties we can write, and after that, which is again less than. So we assume here something. What we assume, delta plus delta. Okay, is equal to 2 delta. Sorry, what we assume here, delta and delta, which is epsilon by 2. 2 into epsilon by 2 is equal to epsilon. So that means these are coming from there actually, because these are also we can get from the things in the same manner from the that function. What we do, like mod of x plus y minus half. So we can write now something. These things we can write in this manners. No, 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 that is not. Actually, when that is satisfied, we are just from the circular neighborhood. We can write the things. Okay, now we come to the other problem. Let function of xy is equal to y sine of 1 upon x plus x sine of 1 upon y, where x not equal to 0, comma y not equal to 0. Prove that function of xy is 0 as x comma y 0 0. Okay, here is the functions defined y into sine of 1 upon x and plus x sine of 1 upon y. Okay, generally we take the square neighborhoods to solve this our problem. Suppose this is tends to 0, xy tends to this one. Solution, let epsilon greater than 0 be given. Mod of function of xy, and limit is also 0 less than epsilon. Or now we write the term function is defined y sine of 1 upon x and plus x into sine of 1 upon y minus 0 less than epsilon. So after that, sine of 1 upon x we can write in two parts. One upon y. And this is okay. Right hand side is okay less than epsilon. Is always be like maybe from the left hand sides the term is like greater than in this manner we are moving. Okay. Or we take like sine of 1 upon x, this modulus plus x sine of 1 upon y less than epsilon. Okay, whatever the value, sine of 1 upon x, maximum value is 1, and sine of 1 upon y, for all values of y, maximum value is 1. So we can write mod 1 plus less than epsilon, since sine of 1 upon x modulus, which is less than equal to 1, and sine of 1 upon y, which is less than equal to 1. Okay, or y minus 0 plus x minus 0 less than epsilon. So therefore, y minus 0 can write epsilon by 2 and x minus 0 less than epsilon by 2. So what epsilon by 2 is, what is delta. So thus, if mod of function of xy by 0 less than epsilon, then there exists a delta such that there exists a delta greater than 0. Okay, epsilon by 2 such that we can write mm, mm, okay, no, it's x minus 0 less than epsilon by 2, which is delta, and mod of y minus 0 less than epsilon by 2 is equal to delta. Hence, this proof is done. Means function of xy tends to 0 as x comma y tends to 0 is 0. Okay, like that the problem may come. Okay, now we come to the continuity. These are all like epsilon delta forms. But it may be, this is okay, fine. But when it's the function xy is defined in the some another way, like xy upon the x square plus y square, so on. For that things, it's little bit difficult. So what you do, you choose any, because we know that when we finding the limit is, which is the independent of the path, as we know that which is the independent of the path. If limit is exist, then this limit is independent of the path along which we approach the point. Okay, AB or 0, 0 something. Mhm. Okay, we see one more example first. Let a function which is defined r square to r be defined as function of xy xy upon x square plus y square comma x comma y not equal to 0, 0. Okay, and this is 0, 0, 0. Prove that limit function of x y tends to 0 0 does not exist. Solutions. Uh, okay, this I okay. Today I'm leaving just 6 7 minutes before, as I need to go some hospitals. Okay, fine. So you try this one. Otherwise, in the next class I will complete these questions. Okay, tomorrow I will complete this one and we continue the continuity. Okay, so that's why
Okay,
I'm
sir.
leaving before something.
एक्सक्यूज मी सर।
Ah, yes.
सर एमसीक्यू में दो क्वेश्चन शायद बोनस होने चाहिए। दो क्वेश्चन सर टू वेरिएबल वाले आ गए थे।
Yes, sir.
दो
Yes, sir.
questions, two
Yes, sir.
variables.
टू वेरिएबल वाले आए थे दो क्वेश्चन।
सर ग्रुप में सेंड कर रहा हूँ मैं क्वेश्चन, प्लीज आप चेक कर लीजिए एक बार।
Ah, okay, okay. I will check it. No issue. Okay, so I will
यस।
do the if it's in the two variables, so I will give you bonus marks. Okay, no issue. So let me check the things. Okay, okay, fine.
Yes, sir.
Yes, sir.
Yes,
यस
sir.
Yes,
सर।
sir.
Thank you, sir.
थैंक यू सर।
Thank
Thank you,
you.
sir. Thank you, sir.
Oh,
Thank
Thank
you,
you,
sir.
sir.
Thank you, sir.